Hello everyone, and today we're going to learn about complex fractions. So strap yourselves in for this, because if it isn't Fun Fraction Friday, it will be now. Alright, so let's take a look at our first example. Now I'm going to show you the long way and the shorter way to do this. So I suggest you watch the long way for at least a couple of times, and then if you want to fast forward to the short way, you're welcome to do that. Okay, but now what we're going to do in the long way is we're going to turn everything into a fraction. And I know what you're saying, well gee, there's fractions all over the place here, so what are we supposed to do? Well, I'm going to take this 4 and make it 4 over 1 and rewrite this as 4 over 1 divided by, because we have divided by, and then we have all this garbage right here. So we're going to have 3/4 minus 3/2. Okay, so we rewrite it first. Then what we're going to do is we're going to find the LCD of our pieces here next. So our LCD. Now these are separate fractions. So LCD in this first one is 1. I don't have to do anything, so perfect. So 4 over 1 divided by. Now here, common denominator is going to be a 4. So we need to tweak this. Oops, not by 4, I'm sorry. Tweak by 2's. Okay. So I'm going to have 3/4 minus 6/4. Okay. Now I'm going to shrink this down, move it up so I have more room. Okay, then our next step, let's work in here. So we're going to have 4 over 1 divided by, now I'm going to combine the tops here. So that's going to be -3 over 4. Now, once we get this down, each bracket here down to 1 fraction each, now we use our rules. So we're going to flip the guy and multiply. Or KFC, or however you keep, change, flip, however you learned it. So 4 over 1 now times, it's going to be -4 over 3. Okay. Now, then what we're going to do is, now that we've done this, now we're going to start using our multiplication rules. Well, can I reduce 4 over 1? No. -4 over 3? No. Can I do 4 and 3? No. Can I do 1 and -4? No. Can't reduce up and down or diagonal, so now we're going to just balance multiply. So 4 times -4 is -16. 1 times 3 is 3. So that right there is our answer. Okay, as fun as that was. Now, like I said, this is the lengthier way to do this, but some people like this. They can see it a lot better. So let's take a look at another one. I'll do a few examples a long way, and then I'll show you the shortcut way. All right, so something a little more advanced. We look like this. So first thing I'm going to do is I'm going to pull this thing apart. So this top piece, 25 over 12 plus x plus 1 over 4 divided by, because it says divided by. Then we have the bottom, 1 over 18 minus x plus 1 over 36. Okay, so now we're going to do the LCD component of each little part, each little bracket here. So my common denominator in the first bracket, 12. So this fraction's all set. This one needs a tweak of 3's. Okay. So doing the math out, we're going to have 25 over 12 plus, and I distribute the 3 to both these because it's a binomial, so 3x plus 3 over 12 divided by, hey, stop it. Okay, now over here, common denominator of these guys is going to be 36. So this one we have to tweak with 2's. This one's all set, but also notice we have this minus here that we don't like, so let's change that to plus and change the signs up here because we want to distribute the negative up. So we're going to have 2 over 36 plus negative x minus 1 over 36. All right, now that we have this, let's combine everything inside the brackets. We can't do anything until we have one number left inside. So let's go across the top, combine like terms. So 25 and 3 is 28. So we're going to have 3x plus 28 all over 12. Now don't reduce anything right now. Let's keep it the way it is. We'll deal with that after. Divided by. Now over here, combining the tops here, we're going to have negative x plus 1 over 36. All right, so now let's make some more room. Okay, so now let's flip the guy and multiply here. So we're going to flip this back piece. So we're going to have 3x plus 28 all over 12. Now times 36 all over, negative x plus 1. All right, so now going back to what we did when we multiplied multiplied rational expressions, let's see if we can factor anything here. So this I can't factor. This, yeah, you could take out a negative 1 if you wanted to. That'll leave you x minus 1. Oh, come on. Okay. All right, but other than that, it really can't factor anything. So now let's start reducing. Like 12 and 36. If they're on the diagonal, I can reduce them. It's multiplication. This is 1. This is 3. Now on the diagonal the other way here, there's a negative 1 out here. I can't reduce it with the 3, and there's nothing out in front of this, so I can't do anything with that. Then we have the x minus 1. Well, there's no x minus 1 up here, so can't do anything with that. So we can't reduce anymore. So now let's multiply this together. Okay, so 3x plus 28 times 3. I would just do this, 3x plus 28. Over, now you're going to have negative 1, x minus 1. Now, depending on your teacher, some of your teachers may say, well, that's not acceptable. They don't like this negative in the denominator. They may say you got to send that up. So you would have negative 3x plus 28, all over x plus minus 1. Okay. Some of your teachers may say, well, you should just distribute all this in now, so you would have 9x plus, that's going to be 84, all over negative x plus 1. Some teachers may say you have to put it back in. Okay, and some teachers may say you could leave it as it was, like this. So again, know your teacher, know how they want you to write your answers, because that's always very important. Okay? All right, so there's that one. So let's take a look at a really difficult one in the long way. All right, so here we go. So let's pull this thing apart. Okay. So we're going to have a over 8 minus 4 over a squared divided by 4 or 4 over 1. Okay, now let's get our common denominator. Now I also see this minus. I'm going to change that to plus and make that negative. Let's fix that right away. So let's get our LCD in the first one. Now I got free and single pieces here, so it's going to be 8a squared. LCD on the second is easy as 1. So that's going to be the easiest we're going to get. All right, so let's create common. Let's create the common denominator. This needs a squared. So we're going to have a cubed over 8a squared plus. Now this needs 8s. That's going to be negative 32 over 8a squared divided by, now here it's just 1, so I don't have to do anything, so 4 over 1. All right, so let's shrink this down a smidge. Okay, Okay. All right, so let's combine like terms on this parenthesis here. So on the top, so we're going to have a cubed minus 32 all over 8a squared. Oops, divided by 4 over 1. All right, now that we got one piece inside the parentheses, now we can flip the guy and multiply here. So we're going to have a cubed minus 32 over 8a squared times 1 over 4. All right, so let's start reducing. Now remember, because of this minus here, folks, this is in a parenthesis. So, do I have any a cubes minus 32 in the bottom? Nope. Can I do anything with the 8 and the a squared with this up here or up above? Nope, because this is in a parenthesis, so I can't cancel the a's or the 8 and the 32. So, we're just multiplying. So, a cubed minus 32 times 1, a cubed minus 32 over, now 8a squared times 4 is going to be 32a squared. Oops. All right, now let me move this up to remind us of some things. Okay. I remind you, this is still in a parenthesis because of this minus sign. You cannot reduce 32 and 32. Can't do that. Okay. You can't go after the a squared and the a cubed because they're in a parenthesis. And there's a minus between them. So you can't do any of that. So this right here is our final answer. Okay. Are we having fun yet? I know this is great stuff. All right. So let's take a look at the easier way. So I know most of you either fast forward here, which is fine, or for those of you who just watched the last 20 minutes of me doing those other problems, you're going to be pretty mad at me because this is the better way to do this. I call this the D'Arville method because Miss D'Arville is the one who showed this to me. Okay, so what we're going to do is I'm going to rewrite this first as 2 over 1 divided by 3 over 2 minus 4 over 3. Now then what Miss D'Arville says, well, first thing, let me change this. I don't like this minus, so we'll do this. What then Miss D'Arville says is we're going to grab the denominator of the denominators, and we're going to use that information to clear out the complex fraction and make it a regular fraction by multiplying all the tops, or the numerators, by the LCD. So what does that mean in English? All right, let's start with the LCD. So, common denominator of 1, 2, and 3 is 6. So I can multiply 1 to 6, 2 by 3 to get 6, and 3 times 2 to 6. So what we're going to do is we're going to use this information, and we're going to times the tops by 6's. And what we're going to do is we're reducing here. So 6 times 2 is 12, divide by 1 is 12. So you're going to have 12. Over, now it's this big division sign here. 6 times 3 is 18, divide by 2 is 9. 6 times negative 4 is negative 24, plus negative 24 divided by 3 is negative 8. And now, let's do the simple math. We have 12 over, so adding a negative is really just saying 9 minus 8, which is just 1, which I reduced to just 12. Here's your answer. All done. Much nicer, huh? Much easier. I like this way much better, but for some folks, they like to see the long way of how to do this. So, all right, let's do another one. All right, let me shrink this down. Now, when it comes to the algebraic expressions, it's not that much more different. Okay, so let's write, well, everything's a fraction, so I really don't have to write much of anything here, but I do need to change this. I don't like this. Okay, so my LCD, the denominator of the denominators, we have m minus 1. And the difference between 5 and 25, those are free and single pieces. So common denominator of 5 and 25 would be 25. Okay. So now, what we're going to do, let me get rid of all this. Okay, so now at this point, we're going to multiply the tops. So we're going to do 25 with m minus 1. Top here, 5, or 25, sorry, m minus 1. Come on. And 25, m minus 1. Okay, so now we're doing is canceling. So this cancels. So then I do 25 times 16, that's going to be 400. Over, now here, 5 and 25 reduce, I make this 5. Okay, so now we're going to do 16 times 5, that's 80. 80 times m is 80m. 16 times 5 is 80 times negative 1 is negative 80. We got to distribute that. Now here on this piece, the 25s completely cancel, so I distribute the negative 16 to both pieces. So I get negative 16m plus 16. Okay, so now let's clean up that bottom now. So 400 over, now 80m minus 16m, that's going to be 64m. Negative 80 plus 16 is negative 64. Okay, so now let's factor the bottom. 400 over, you take out 64, leaving m minus 1. Okay, now you're just reducing. So 4 and 400 I can reduce definitely by 4s or even 8s. I'll do by 8. So that's going to be 50 over 8, which I then can reduce again. 50 and 8 can be reduced by 2, so you're going to get 25 over 4. So we're going to have 25 over 4m minus 1. Boom. And there's that one. A little confusing, but again, nothing too terrible, unlike the long way, which definitely gets pretty ugly pretty fast. All right, let's move on to the next one. Oops, hey. All right, so this one, let me rewrite it. So we're gonna have x squared over 9 plus 1/4 over 6x over 1. All right, so let's get the denominator of the denominators. So my common denominator of 9, 4, and 1 is 36. Okay, so I'm going to times this by 36. I'm going to do this by 36, and I'm going to do this by 36. Okay, so let's start to cancel. 36 and 9, this goes away, and this drops down to 4. So 4 times the x squared, 4x squared. 36 and 4, this cancels down, drops down to 9. So 9 times 1 is plus 9 over. All right, so can't do much anything here, so let's multiply. That's going to be 216x. Now don't forget, because of this plus here, these are held in parentheses. They're one piece. So now at this point, let's try to reduce, well, see if I can factor the top. It's awfully tempting. It looks good as difference of square, but we have a plus here, which means that's not difference of squares. So that stays as is. The bottom I can't do anything with. So since there's no free and single pieces on the outside here to reduce the 216x with, can't reduce there. There's no 4x squared plus 9 in the bottom, so I can't do anything there either. So that means this right here is all I can do to this. And you're done. Alright folks, so that's it for now. So hopefully you learned a lot, and if you need my help, please feel free to let me know. Otherwise, I will see you in the next video.